need to talk a little bit about qualitative descriptions of motion. So qualitative means that we are trying to describe things accurately and completely as possible without trying to get bogged down in all of the numbers. So all the examples I'm going to be using in this video are qualitative in nature, meaning that we want to get the right idea, but as you're kind of using your imagination and thinking a little bit about how the motion of this object could look. Could be a car, could be a ball rolling back and forth, or a person walking. As you're kind of imagining what the motion might look like, you want to be as accurate and as complete as you can be. There are 4 things that help us describe the motion, either qualitatively or with numbers. One is a position time graph, one is a velocity time graph, one is a motion map, and one is a written or verbal description. Given any one of those 4 things, you ought to be able to come up with the other 3. So this first example that I have shows a position time graph for an object. I like to start with the written description. I feel like that's about the easiest, as once I can put it into words, I can often then figure out where I need to go next. I notice that this object starts at some location, not 0, travels forwards or to the right at a relatively high speed, turns around and goes backwards to the left in the negative direction at a slightly slower speed. I tell that by the slope, steep slope, not a steep slope, and then stops for a time. This was intended to be horizontal. So I would write that out. The object moves to the right at a faster speed, then reverses and moves left at a slower speed, then stops. Right? It's important to use words like faster and slower, comparative words, to use words like constant. If it's moving at a constant speed, I probably could have used right at a faster constant speed, reverses, moves left at a slower constant speed. Probably should have added constant to that description. Stops, right? Stops moving, remains motionless is another way you can say that, remains motionless for a time. Once I have the written description, then coming up with the motion map is relatively straightforward. I see that it starts not at 0, so this corner right here would be the 0 point on the motion map. It starts at some place positive but not 0. Maybe that's here. Okay. I like to label the first location as 0 seconds, so it's easy to know where to start. And it's going to move to the right at a fairly high rate of speed, so I'm going to put the dots kind of far apart. I'm looking for rough, even spacing. Okay. I'm going to draw long arrows to represent a high velocity. Okay. Then, when it gets to this point, it reverses direction. Now, I don't want to draw arrows back on top of each other. It goes backwards, and it goes backwards at a slower speed, so maybe I'll put the dots here. Okay. And they're going to be closer together than before because it's moving at a slower speed. Again, 3 or 4 dots for each line segment is usually sufficient. And then it stops and stays at this location for a while. It doesn't, if I draw above the number line or below the number line or go up or down when I'm drawing these dots, it doesn't really matter. Okay, it's not important if I'm above or below that line or which way if I'm moving up or down. It's that I'm going left and right and how far apart the dots are and how big the arrows are on the motion map that matters. To draw the velocity time graph, I would start with knowing that this is a fairly large positive number, then a smaller negative number, and then 0. So I would start maybe up kind of high here for the first section, drop down but not quite as far for the second section, and then the last section would be right on the line. It's important that this distance here be bigger than this distance here because this slope is bigger than that slope. And so that's how I got those distances to be what they are. If I were, let's try another example. Here on the the left, we see another example of the same thing. The car is moving to the left kind of quickly, then reverses direction and goes to the right kind of slowly. So that's what I wrote down here. 0 seconds labeled, moving to the left kind of fast, then moving to the right kind of slowly. And then on the velocity time graph, again, kind of fast, so it's a little lower here and not quite as high here on the positive side, to give it a not quite as fast positive velocity. This last example, again, the same thing, only this time we started with a velocity time graph. So this is a little different. It's the same idea, but I just have to interpret the velocity time graph. Because these lines are positive, I know it's moving to the right. Because this one is a smaller, or not as high as this one, slower, stopped, faster. So when I write my verbal description, I want to say something along those lines. The object moves to the right slowly, then stops, then moves to the right again, but much faster. And so on my position time graph, I have it moving to the right slowly, then stopped, then moving faster. Slowly because the dots are close together and the arrows are small. Faster because the dots are farther apart and the arrows are bigger. And then finally on my position time graph, moving to the right with a not very big slope because it's slow, then stopped, so it's horizontal, and then moving to the right again quickly with a steeper slope as it points up. I could start the position time graph anywhere along the line here as long as it had this basic shape. So the shape is what matters. I can't tell from the velocity time graph exactly where it starts. The reason I started there on the position time graph is because I started at some place not 0 on the motion map. Okay? I could have started at 0. This whole shape would shift down a little bit and look the same, right? It'd be parallel, just like that, as it goes over that shape.